welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buetow, Editor-in-Chief of PCD&F and Circuits Assembly. First, a word from today's sponsor. This podcast is brought to you by Turnkey Pro from Sierra Circuits. What if you could source your components, upload your specs, and receive an instant quote in less than 15 minutes? What if your designs could be fabricated, assembled, and delivered to your door in 5 days with a guarantee of 0 defects? Then try Turnkey Pro by Sierra Circuits for your next design and use promo code PCBChat, one word, to receive $200 off your next order. It goes without saying that no matter how fast product developers move, there is pressure to pick up the pace. Today's guest is still fairly new to the industry, but he has a vision for just how the industry might speed the product development cycle. Gowtham Ramachandran is founder of Trace, a 3-year-old startup company based in Toronto. His idea is a so-called desktop microfactory that automates much of the development workflow. Gowtham, thanks for joining us on PCB Chat.
Hey, Mike. Thanks a lot for having me.
So many solutions aim at fixing one aspect of a process. Your concept, however, if I understand it right, tries to take on the entire product development workflow and reimagines it completely. Is that correct?
That's correct. You actually hit the nail on exactly what it is that we're trying to do and how we're looking at the problem differently. So, at least when we started working on Trace, the company itself, our idea was to accelerate the PCB fabrication process. And we're working on this 3D printer for electronics where we made single and double layer PCBs really fast. But once we brought that product to market and we started talking to developers, we realized that we didn't have too much product market fit. And developers kept talking about the problems that they faced before and after they fabricate a board. And that really was our aha moment where we said, hey, it's not about accelerating one workflow, but to really make product development faster, we've got to look at the complete life cycle from design to manufacturing to assembly to diagnostics. And so we took a step back and we said, let's look at the entire development experience and see if we can build a model where we accelerate the entire process.
Now, that's a really ambitious thing, of course, right? And you're early 30s?
Early 30s, yes. 31 to be exact.
Yeah, 31. Great. Okay. So, tell me a little bit about your background and maybe your team's background, right? So did you have direct experience in the electronics development process, or is this something that you came at from the outside saying, I've got an idea now, what's an industry I can apply that idea to?
So it really comes down to our own experience. That is my co-founder, Varun, and I. We're both engineers. I did my mechanical engineering from the University of Toronto. And Varun, my CTO, has a PhD in computer science from the University of Toronto. Just between the two of us, we built all sorts of hardware, right? From IoT devices to solar cells, to being a part of race car teams, to even augmented reality devices. And it really came down to not being able to meet deadlines and being delayed every single time. And most often the problem was with the electronics, and we just couldn't figure it out. So that really is what inspired us to think about the problem more and to really try fixing or creating a new solution to this problem of not being able to develop product really fast.
And how many folks do you have on your team now?
We're a team of 6 right now.
Mm-hmm. And you mentioned race car team. So tell me a little bit more about that.
Yeah, so with the race car team, I think this was an undergrad when I was in India, and it was a project where you develop this solar cell based race car and you race against a bunch of teams. And I was a mechanical engineer on the team, so I was focused more on developing the frame for our car itself, not so much the electronics. But that really was almost my first experience seeing electronics engineers on the team struggle with developing the boards that need to go to different parts of the control systems and stuff. So that was my first, foray into what it takes to develop electronics. And just after that, just through my undergrad and masters, I worked on a bunch of just smaller projects, and I faced the pain points myself.
And you ended up in Toronto to get your MBA?
To do my master's in mechanical engineering first, and then my MBA. Yeah, so
got it.
Okay. Did a bunch of school.
As part of your research, it looks like you looked at the capacity utilization among North American fabricators and perhaps relative to their Asian counterparts. What did you find and how did that influence your thinking?
So, like I mentioned, we looked at the complete life cycle, and manufacturing is a key part of this life cycle. Another key constraint we considered was that when you're developing electronics, you're looking at making, say, 5, 10, or 50 units, maybe 100 units tops. So, just for that segment of the market, when you look at it in terms of just how much quantity people manufacture, we looked at what stopped a manufacturing company from making them really fast. And what we realized was that it all came down to capacity. When you look at manufacturing and manufacturers, PCB fabricators especially, they're all set up for mass manufacturing boards. And when you send orders for 5, 10, or even 50 boards, you often have to wait several days to aggregate enough orders to operate their factories. So we found a lot of inefficiencies here, given that there's a lot of fabricators both in North America and in China. And our model really is to be able to aggregate enough low volume demand on our platform in a way that we're able to aggregate these orders and send them to a small number of fabricators instead of how the current workflow works, which is there's a lot of demand, you work with a lot of fabricators, and it's just inefficient across the board. And just through the research, what we found was that I think average capacity was about 50 to 60% in terms of utilizations, based on this one study done by, I believe it was the US DOE. I'm actually not too sure. But that's essentially what we found, which is low capacity utilizations, which is driving inefficiencies. And we want to be able to help our fabrication and assembly partners increase their capacities.
Right. And I know that study. I think that was the U.S. Department of Commerce, and
That's correct.
the right. And so so that's one of the things that is interesting, right? Because of course the quick turn prototype shops, if their capacity utilization's 80, 90%, that means that it's hard for them to take on other quick turn orders, right? So their whole process is based around having some headroom, I think, in order to take on things that have a very short lead time and for which they can charge a premium.
That's correct.
So you see this as an opportunity to, hey, look, you might be at 40 or 50%, and we're not saying you need to go to 100%, but we think we can help you get to, say, 70 to 75%.
That's exactly right. And a lot of the orders that we want to bring to our manufacturing partners are the high value orders where it's low volume, plus your margins are typically higher in this domain. So instead of you getting, say, 10 low volume orders per day, if we can bring, say, 50 low volume orders per day over time, that's the value we believe we can add to our partners as well.
Now, this is an acronym heavy industry, as you know, and you've managed to coin a new one. You call it computer aided physical editing, or CAPE. And you describe this as, quote, manipulating physical PCBs in ways unimaginable today. What does that mean?
Yes. So just taking a step back, I'd just like to tell you a bit more about the platform itself or the goal of our platform. So the way we look at it is the workflow we want to create for developers is you have an idea, you use your CAD tool to design a circuit board, and we want to make every process almost from there a one-click experience for you, the designer. So you have all these integrations with your CAD tools, which you can add on to whatever CAD tool you're using. And you'll be able to export your designs onto our platform with a few clicks. We give you all the manufacturing options and lead times to fabricate boards, source components, assemble, etc. And you choose what you'd like to do with a few clicks. And once you get your boards back, you then have all of these desktop workflows from assembling boards and components to diagnosing to testing to even reworking if you have to. And our goal is to be able to automate all of these desktop workflows. And to automate these workflows is the reason for which we're building up this desktop hardware machine, which we're calling a Microfactory, which can do a bunch of these workflows and help you automate it. So the CAPE feature is part of the reworking process, and we're calling computer-aided physical editing because the vision we have is, say, you have this fully assembled circuit board, and you want to test a bunch of new resistors for the same board. So instead of having to go through the complete iteration process, we want to give you the power to be able to use robotics and a hardware machine to remove a component and then go to another component, pick it up, and place it. And you can even do things like having 2 or 3 boards side by side and move components around within the boards itself. And we want to automate that complete process. So we try to come up with a term for it. We like the term CAPE. Uh, Acronym is, like you mentioned, computer-aided physical editing, and these are features that we are doing R&D on right now.
Walk me through, if I'm a design engineer Walk me through how exactly I would use your platform. Typically, I'm sitting in the room, at the start of project kickoff meeting, and I've got the folks from, maybe I have an SI guy in the room, and I might have the mechanical guy and a hardware engineer, and I might have the firmware guy in there, and we have somebody that's sort of giving us, here's what the enclosure looks like, and here's what we want you to be able to make this product do. Here are the features that we want. And now you have to go, design the board and pick the components, and then the assembly guys have to put the components on and all that. So I'm that design engineer. How is this going to change my life? We talk about automation, but what does that really mean for me in the trenches?
Absolutely. So, say you have an idea and you know exactly what you're building. You start by designing. Let's say you're designing an RTM, for example, and you complete your designs. So you take this file, go onto our platform, upload it. Once you upload it, you'll see three manufacturing options. You'll be able to fabricate the boards. You'll be able to source components. You can use our turnkey services, which is the complete process itself. And you'll have multiple lead times and prices for these lead times, right from the fastest to say 20 days and the absolute cheapest prices you can get. And you can choose which option you want. And say, for instance, time matters for this specific project, and you want to get to the assemble board as soon as possible. And you decide that you can assemble the boards yourself. So, say you order 5 boards and components for the boards, and with, say, 3-day lead times, you get a price for it, you click. Then in 3 days, you get your boards and components back. You take these parts and you place them on our desktop hardware machine. You click a few buttons, and the assembly process is completely automated. So we apply solder, we pick up components, we place them, we heat them up, and you'll get a board in about, say, 20, 30 minutes. And once that's done, we automate parts of diagnostics, testing, reworking as well. We have cameras in there, we have probes in there, we have heating systems, etc. I can go into exactly how the assembly works. It's a bit different from existing, say, reel-based systems, but at a high level, that's the workflow we're trying to create for developers.
Got it. And so the would the design engineer or somebody from procurement actually choose who the vendor would be, or is that something that Trace would assign based on the characteristics and the time frame and perhaps even the price that the customer has established?
That's correct. So for the first version of the platform, we're just going to give you a pricing. And again, we're trying to make this work for the 5, 10, 50 quantity orders. We're not focused on the bigger orders itself. And we're focused on those orders where you just want to get things done, tested really fast. So the experience we're enabling right now is you just come to us, we give you pricing, and you decide what works for you. We then figure out who the best vendor to source from is based on your location and based on just what lead times you're looking for, etc. And we make sure the parts get to you. So short answer is you just come to us for quotes. We figure everything else out in the back end.
And do you already have a vendor list? Different fabricators that you're working with.
We have a few in Toronto actually. So we're piloting with a couple of teams in Toronto, and we use a couple of fabricators, assemblers, and distributors here. We've been using them to source parts and to send them to our pilot customers. So we don't have an exhaustive list, but we do have a small list. Yes.
Is that something you're looking to expand in the near future?
Absolutely, absolutely. So we're just trying to test, or we are in the pilot phase where we're working with a few customers right now just to refine various parts of the workflow itself. The goal for us is to be able to get a few design tools up and running by the end of October and launch through our website, and just over time expand on the first version of the platform to add more and more features and eventually get the hardware up and running. So that's where we are right now.
Manufacturers and assemblers, of course, have lots of software. It's line and machine based, factory level MES, backroom ERP, and so on. It sounds to me like Trace actually intersects with that. You're not really necessarily trying to replace what they're doing. You're actually just going another layer on top.
Kind of. I'd say that like our goal or our focus really is a developer's experience, and we want to unlock as much efficiencies as possible in the complete workflow. So again, if you're sending me files, we see our role as being able to take those files, process it, and give data to our partners that is digestible for them. They don't have to do and too much of the grunt work in terms of getting back to customers, etc., or developers. So the goal really is to be able to crunch all that data and give it to our vendors in a form factor or in a format that is ideal for their setup. So they can focus on what they do really well, which is fabricating, assembling, manufacturing, etc. And we figure out everything before and after, and we just want to bring orders to them and make sure they run their systems efficiently.
So do you actually have to translate data coming out of the CAD systems?
We will have to in the future, yes. That's not a problem we're working on right now, but definitely there's a ton of data formats, right? So it's about making sure it works with the formats that our vendors use.
You mentioned augmented reality on your site. I
Mhm.
think we've seen that in one form or another with companies like Inspect AR. What does that mean in the context of your platform?
That's correct. I'm going to say there will be an overlap with what Inspect AR in terms of features that they're building out is, but the convenience that we're bringing right now is that you don't need hardware. Just building out our own hardware, our machine has taught us just how annoying it is to get the right cameras in place and to be able to focus on things, etc. So again, the experience for you will be you have these boards under this magic machine or the hardware, and things just work. You can use software to drive various parts of the workflow. So those are I guess, the annoyances that we're trying to remove with the machine or with the hardware.
So you mentioned that you're in pilot. So how far, how much longer until you are ready for prime time, as they say?
So again, like I mentioned, first week of November is when we want to release the first version of our platform. So we'll have a few design tools just so our customers or developers can get a sense of what we are about in terms of how we're approaching things differently. But the goal is to be able to launch features sequentially over the next 12 to 16 months. And if it's specifically the hardware, it's going to be Q3 next year. That's our plan. But till then, we won't be able to release features sequentially, which adds value incrementally with different parts of the workflow.
So we talked a bit about the fabrication side. Let's talk about assembly and what you're working on in that area, because that really sounds to be the one that you're really tackling right now.
For sure. So, in terms of the problem with assembly that we'd like to tackle is your manual workflows when you have to use stencils, apply paste, pick and place components with tweezers, etc. And that's the part of the process we're looking to automate. And if you look at automated PCB assembly systems on your desktop, it's typically the reel-based systems where you need to insert reels of various components. And they're good when you want to assemble, say, 50 or 100 boards. But when you're making 5 or 10 boards, there's just so much setup cost and time involved that it simply makes no sense to do it. So that's specifically the applications that we're building our machine out for. And we're just looking at automated assembly fundamentally differently. So the way our machine assembles components is we use computer vision extensively. And the experience we want to enable is you throw these boards on, you throw these components on, even loose components, reels, etc., and everything else gets automated. So we use computer vision to look at PCBs. We already have your CAD files, and we match them to the pads there. We use computer vision to read text on components from the top. So we're able to identify a ton of components already. And we have another camera at the bottom that looks at footprints and matches footprints precisely to the boards itself. So we start by soldering these boards, and then our pick and place system picks up components, takes it to the second camera, which looks at footprints from the bottom, make sure that it's assembling correctly based on the pads on the PCB itself, and that's basically how we're fundamentally different in terms of how assembly happens today. And I think that's just a key feature that I wanted to highlight compared to what's status quo right now.
Right. For a lot of prototype assembly, right, you still need to buy placement machine. Obviously, you have to buy a printer. You're going to buy an AOI, maybe you even buy the SPI. That's a lot of money, plus the conveyors that are attaching everything together. And then you've got the reflow oven at the back end. There's a lot of investment in equipment. And what you're looking at right now is something that would kind of almost self-contain all that, correct?
That's exactly right. Yeah.
Yeah, in probably a much smaller footprint.
Yeah. It's probably like a 3D printer that you have on your desktop. So
Yeah.
um,
Wow.
pretty tiny.
Yeah. Is it fair to say that the customer investment will be just a fraction as well of the cost of a full SMT line?
Yes, absolutely. We want to make this as affordable as possible to as many users as possible. So we're trying to bring this to market at the cheapest price point that we possibly can.
And would this really just be aimed at developers, or do you see a market for traditional EMS companies or even OEMs, research labs, those types of operations?
Yeah, so right now our focus is just developers, and we're trying to build a machine that works really well for them. And I'm going to say if it works for developers, it's going to work for research labs and probably EMS as well. But we haven't really dug deep enough for us to be able to understand if this has strong fit with EMS companies. Perhaps for a small number of applications, but our focus is just developers right now. We want to build a machine that absolutely changes their workflows when they're doing things on the desktop.
Yeah, I mean, 10 years ago, I was said, it's just not going to fit their profile. But now, I visit a lot of EMS shops. I'm starting to get back in, now that the COVID protocols are being a bit relaxed. And I'm seeing plenty of 3D printers. And 2 years ago, I could have counted the number of 3D printers I saw at EMS shops on one hand. Now they're pretty commonplace. That's happened in 24 months. And so, I do think that even the bigger guys are looking for opportunities to speed up processes any way they can, and they're being perhaps a little bit more creative than they used to insofar as broadening their search for tools or platforms that might fulfill that goal.
Yeah, and it makes sense, right? So the machines that they have right now is more industrial, has better quality, and it probably meets goals for most of their orders. But there's a lot of room for improvement when it comes specifically to low volume and smaller quantities. And you're right, I do believe that this does have applications there as well. Um, but again, our focus right now is developers, and that's where we're going to focus all of our energies on at the moment.
And of course, developers, they're not just doing proof of concept, but they may actually want to use it once it's once it's assembled. Like they're not, they may not even want to build 5 pieces. They might just want, one or two or three or something like that.
Yeah, exactly. And that's the flexibility that we want to give developers. And also, if you're even trying to do things like, say, try test out new components on the same boards, right? You can assemble 3 and then test if it works and use the few other boards that you have to try out new components, etc. And again, it just comes down to giving you the options so you can iterate really fast and really focus on what matters, which is often not you picking up components and placing them in tweezers.
Trace has a website. Do you want to give the details?
Yes, so it's trace.so. We will be updating our websites pretty frequently over the next month and a half as we get closer to launching that first version of the platform. But you will be able to check us out at trace.so. And if you'd like to connect with me or contact me, my name is Gowtham. That's Gowtham at trace.so. And I'd love to say hello.
Great. Well, our guest today has been Gowtham Ramachandran of Trace. Thanks again for joining us.
Absolutely. Thank you so much for your time, and thanks for having me on your show.
This podcast has been brought to you by Turnkey Pro from Sierra Circuits. Turnkey Pro is the simplest platform for sourcing all your components, uploading specs for fabrication and assembly, and receiving an instant quote, all online and in less than 15 minutes. Try Turnkey Pro by Sierra Circuits today and use the promo code PCBChat to receive $200 off your next order. For PCB Chat, this is Mike Buetow. Have a nice day.